Section 2.5, the distributive property. This is a picture I took, and this building is actually across the street from the Coliseum. And the building itself was pretty cool, but the really neat thing about this building is its story. With this particular building, it was a mausoleum. There was a ruler whose love died, and she was very precious to him and very important, so he built this mausoleum to house her tomb. Well, years passed, and the ruler passes away as well. And they said, okay, well, we can't have, this guy's wife have this ginormous mausoleum and then him just have this small one. So they decided they were going to tear this down and build a bigger one for him. Well, that didn't really work out so well for them because the construction was just too good. If you look very closely right here, let's see, I may be able to zoom in a little bit on this for you. But right here, you can see there's kind of these big gashes or grooves. That was where the ropes were put around, and they had all these men and all these horses trying to pull this building down, and they'd built it too strong. His love for her was too strong, and it just couldn't be toppled by any man. So I thought it was kind of a neat story. So they ended up building a tomb around the tomb to house the ruler and his wife. So section 2.5, the distributive property. First, some vocabulary words. A term. Terms are parts of an expression that are added together. A coefficient, that's just a fancy name for the number in front of a variable. A constant term is a term that appears without a variable, or a number that appears without a variable. And lastly, like terms are terms with the same variable and the same exponent. Example 1, we're going to identify the terms, like terms, coefficients, and constant terms. So firstly, let's look at the terms. The terms, we've got 4 terms in this particular expression. Negative 2x is a term. Remember, terms are things that are added together. So since this is a negative 8 here, I'm going to do a leave change opposite with it. So it is adding and make it a negative 8. So my terms are negative 2x, negative 8, 6x, and 5. My like terms are the ones that have the same variable and the same exponent. So I have 2 pairs of like terms. One pair is negative 2x and 6x. The other pair is negative 8 and 5. So those are my like terms. Coefficients are those numbers in front. So my coefficients are negative 2 and 6. And my constant terms are terms without any variable at all. So negative 8 and 5 are my constant terms. In the past, my students have called this the rainbow distributive property for reasons you'll see very shortly. But here's a little video clip from Brain Pops to kind of describe the distributive property a little further.
Dear Tim and Moby, what is the distributive property? From Rachel. Well, we can use the distributive property to figure out how many animals are coming in today. 5 trucks are coming today, and each one is carrying 4 cows and 11 chickens. So that's 5 trucks times 4 cows plus 11 chickens. There are a couple ways to solve this problem. Remember that we work with the parentheses first. It looks like in each truck there are 4 plus 11 is 15, and then we have 5 trucks, so 5 times 15 will get us our answer. So we have 75 animals coming in today. But say you don't have a calculator handy. According to the distributive property, 5 times the quantity of 4 plus 11 is the same thing as 5 times 4 plus 5 times 11. This makes it easier. 5 times 4 is 20, and 5 times 11 is 55. And 20 plus 55 equals 75. So both methods get us 75 as the answer. We just use the distributive property to figure it out without a calculator. For any numbers a, b, and c, a times the quantity b plus c is equal to a times b plus a times c. Right. You can also say that a quantity b plus c times a is equal to b times a plus c times a. See, if you used the distributive property, it would have been easier to figure out how many animals were coming in today. And then you could have built the fence before they got here.
So the distributive property, if you have a times the sum of b and c, that's the equivalent of taking a times each piece, or taking ab plus ac. Let's look at an example. Example 2, I've got -3 times the sum of x and 6. Well, that means I can just distribute. I can take -3 times x and get -3x. And then I can take -3 times 6 and get a -18 or -18. You can either put -3x minus 18, or you can have -3x plus -18. Either of those will work, and both are equivalent. Let's look at this one. The sum of n and 5 times n. Even though the n is behind our n plus 5, it's still going to work the same way. I'm going to take n times n. N times n is going to give me n to the second power, or n squared. Then I'm going to take n times 5. So I'll end up with n squared plus 5n. Try this example on your own. Make sure you distribute completely to each piece. Pause your video at this time. Did you get 3y squared minus 36y? If so, great job. If not, go back and see if you can catch your mistake. Our last example looks like this. It doesn't really seem like there's too much going on in this problem. But I do, in fact, have something in front of the parentheses. And in this case, that something is a negative. So all I'm going to do is distribute that negative to each thing inside my parentheses. And all that's going to do, that's going to change the sign. So that'll be -8 plus x. This answer is okay, but the preferred answer is to go ahead and write with your variable first. So in this case, we could write it as x plus -8, or you can write it as, I wouldn't write it, x minus 8. Any of those three are equivalent, so any of those three will be accepted. For homework tonight, complete the following 6 problems. Make sure to distribute completely and watch your signs. We will go over these first thing tomorrow.